Hello everyone, we will be starting today with projectile motion. Alright, so what is projectile motion? It is a combination of vertical motion, which is right here, and horizontal motion, which makes the third, which is projectile motion. And over here, we have to take the y and x axis separately. So that means we have to take this as u sine theta and u cos theta. So we have to take the vertical speed and the horizontal speed separately. So how do you do that? Well, you have to resolve the vector. So for example, this is equal to u sine theta, right? Because it is equal to u 5 times 3 upon 5. So that means this is 3 meters per second. And this is u cos theta. That means it is equal to 5 times 4 upon 5, which is equal to 4. So that is just an example if u is equal to 5 meters per second. Alright, so now let's find out the total time, range and height of a projectile. The displacement over here is known as the range. So the ball going from here all the way from here is known as range. Alright, so r is equal to u square sine 2 theta upon g, or 2u square sine theta cos theta upon g, because sine 2 theta is equal to sine theta cos theta. Alright, so we take that and apply it over here, and we get r is equal to either this or this. Now let's talk about the height. So what is the maximum height that this projectile can go? It is equal to now let's actually derive this. What we do over here is, let's take s is equal to actually let me just give you the formula and then let's do it. The derivation equal to u square sine square theta upon g. Alright, so over here we know that the this is 2g, sorry. So we know that in motion in one dimension, h, the total height, the maximum height, is equal to u square upon 2g. So we take this formula and we apply it over here. But one important thing is, the maximum height does not depend on the x. Alright, it does not depend on the x speed at all. It only depends on the y speed. So that is the speed in the vertical direction, which is vy. Alright, so the ball will go up here and it will come down, and this is the maximum height reached. Alright, this is vy and this is vx. Now let's take the total time taken. Now can you guess this? Well, time in motion in one dimension is equal to 2u upon g, but we know that we have to take the y-axis, the speed in the y direction, independent. So that means we have to take over here u sine theta, and this is u cos theta. So that means it is equal to 2u sine theta upon g. So these are the three formulae that you need to remember. Very important. Alright, these are the three very important formulae that you need to do. Now let's take an example of a projectile motion question. So let's say a ball is thrown. This is question 1. A ball is thrown at an angle of 30 degrees and with a speed of, let's say, 10 meters per second, then we want to find the speed, then we want to find time, range and maximum height. Alright, so first let's find out the time. Now we know that time is equal to 2 u sine theta. Before we do this, actually let's just take the speeds in the in the horizontal direction and the vertical direction. Alright, so the speed in the vertical direction is equal to u sine theta. So that is equal to u times sine theta, sine 30 degrees. So that is equal to 10 times 1 by 2, which is equal to 5 over here. And in the horizontal direction, in the x direction, it is equal to u times cos 30 degrees, which is equal to 10 times root 3 upon 2, which is equal to 5 root 3. Alright, so this is equal to 2 u sine theta. Now we do not have to calculate sine theta again. We can just take the value of 2 u sine theta, which you have over here, which is 5 root 3. So it equal to 2 times 5 root 3 upon 10. Alright, 2 5s are 10 and 5 cancel. Root 3 seconds is the total time taken. Then let's find out the maximum height, which is equal to u square sine square theta upon 2g, which is equal to now u square sine square theta is just u sine theta whole square upon 2g, which is equal to 5 root 3 whole square upon 220. Since 2g is 2 times 10, which is 20, this is equal to 25 times 3 upon 20, which is equal to 75 upon 20, which is equal to 15.4. It is equal to around, how many, 15 upon 4 is equal to how much? Around like 15 upon 4, 3s are 12, 3, 7, around 3.7 seconds. Then let's find out the maximum range, which is equal to 2 u sine 2 theta upon g, u square sine theta upon g, which is equal to 100 times sine 2 theta. Now sine 2 theta, alright, let's just look at this for a second. 2 theta means 2 times 30 degrees, which is equal to 60 degrees. So that means it is equal to 100, which is u square, times sine of 60 degrees upon 10. 10 get cancelled. It is equal to 10 times sine 60 is root 3 by 2, which is equal to 5 root 3 meter. Alright, so that is the maximum range that it can go. So let's give you another example. So I also want to tell you a really important thing, that while the y-axis slows down and then when it's dropping it increases, the u, or the speed in the horizontal direction always stays constant. It does not change, it never changes. Alright, so that means at the maximum height, when the speed in the y direction is equal to 0, that means the speed of the x direction will always be constant. That means the speed in the x direction is just u cos theta. Alright, so that means the speed of the ball at the highest point is equal to u cos theta. Alright, so now let's take an example. The speed of a ball at the highest point alright, at the highest point is half of the initial velocity at which the ball was thrown. Alright, so that means u cos theta, alright, which is the speed at the highest point, is equal to half times the initial velocity, which is u, at which the ball was thrown. Alright, what is theta? Alright, we want to find theta over here. So u cos theta is equal to half u get cancelled. That means cos theta is equal to 1 by 2. That means theta is equal to 60 degrees, as cos 60 degrees is equal to 1 by 2. That means theta is 60 degrees. That means the angle at which the ball was thrown is 60 degrees. Alright. So I hope you like this video. In the next video, we'll be talking about projectile motion when it is thrown horizontally off a cliff. Like this. Alright, when theta is equal to 0 degrees. Alright. Thanks for watching. Bye.